So last lesson we looked at the graphs of sine, cosine and tan, and this time we're going to take a look at the reciprocal graphs, so in other words cosecant, secant and cotangent. So if we can find a few easy points on that graph, sometimes that helps to plot. So if we know that 0 here, if we do 1 divided by 0 we get error, which actually means it's undefined, which actually tells you there's going to be an asymptote at 0 on the reciprocal graph. Now at 90 degrees we get 1, do the reciprocal of 1 we get 1, so we know that's one of our points. Back to 180 we get 0, 1 over 0 is going to be undefined, so we've got another asymptote at 180. 270 we got negative 1, the reciprocal of negative 1 is also negative 1. And at 360 we got 0, so when we do the reciprocal we're going to get an asymptote here. And if you look at just those few points, that could be enough to be able to plot that graph. Now what you actually might notice, and probably the easiest way to remember this graph is, what you do is we take this part here, this curve, and then we just flip it over, so it comes like this. And then the same for this here, this U shape, flip it upside down, and it becomes this, and then with the asymptotes. So that's your graph for cosecant. Now we can do the same sort of thing actually when we do cosine. So let me reveal the graph so we can see. Asymptotes, well we've got 0, because 1 divided by 0 is going to be undefined, so we've got those two asymptotes. And then we take this curve, flip it upside down, take the U shape, flip it upside down, and then take this shape here and do the same thing, reflect that one round as well. And when we get to tan, we can do the same idea. Anything divided by 0 is going to be undefined, so we're going to have an asymptote here. 180 is also 0, so that'll be undefined as well once we do the reciprocal. And that's your graph for cotangent. So it sort of looks very similar to tan. You can see the asymptotes there, so it repeats after 180 the same, but it sort of goes in the opposite direction. So the zeros for this one are 90, because 1 divided by undefined turns out to be 0, and the same for 270 as well. So those are some 3 other graphs that you should add to your notes, and make sure that you understand the properties of those as well. Now we're going to build on the work that we did in lesson 2. This is our 3rd lesson. This is solving quadratic trig equations. And we've put our limits here. We're going to stick with degrees, and we're going to go from 0 to 360. A couple of ways you can solve this. Really what we're looking to try and do is, if it's equal to 0, we're going to try and factor. And then we can set either of the sets of parentheses equal to 0. Now for this one I could do the opposite, subtract 1, which is add 1, so you get sine squared equals 1. Do the square root, and then you get sine x equals 1. But you've got to be very careful if you do that, because also you could have negative 1. With there being the square root, there's 2 possible answers. So actually for this one I prefer to factor, so difference of squares for this question. With both of these being perfect squares here, sine x times sine x, 1 times 1. We have 1 positive and 1 negative, so sine x minus 1, sine x plus 1. And then if it equals 0, we can either say this is 0 or this is 0. So for the first one, sine x minus 1 equals 0, rearrange it, we get sine x equals 1. And for our second equation, this one here, when this equals 0, if we rearrange it, we get sine x equals negative 1. Now with some more practice, we should be able to figure out where those points are anyway. So here's my graph of sine. It equals 1, you can see at 90 degrees, and that's the only place between 0 and 360. And for negative 1, you can see that it's 270. And as you get more and more familiar with those pictures, you should be able to imagine that in your head. And therefore that's our answers, 90 and 270. Now for our second example, once again it's equal to 0, we've got 2 terms, we're going to see if we can factor. Notice the common factor here, both of these have sine x. So we take sine x as a common factor. Sine x times 1 is sine x, and sine x times negative 2 tan x gives us this expression here. And then we solve as well. Notice for this question, no equals 2 on the 0, so they're trying to catch us out here, but we can have equal to 360. So when we solve this, when does sine x equal 0, and that's actually why I pointed this one out. If we take a look at the graph for this one, or look at your picture, it would be 0, 180 and 360. But we don't have equal to 0, so we've got to ignore that solution. So we're only going to have 180 and 360. Now for this one here equals to 0, rearrange this equation and solve for tan x, and you should find that tan x equals 1/2. Do inverse tan, you get 27 degrees, and then for tan, to find any additional answers, simply add on 180, and if you add on 180 again, you would get 387, which is too big for this question because we're only up to 360. Notice I didn't include 0 here, because it doesn't say equal to. Now our last example, sometimes questions like this, it's easier if you're not familiar with this, or you don't feel comfortable to write the question like this. So in other words, where it says sine x, just put x. And then we can actually factor this. So if you were to factor that, you'd get x minus 4x plus 1, and then you just put it back at the end where it says x plus sine x. And then solve each one individually. So sine x minus 4 equals 0, bring the negative 4 across, and sine x never equals 4 because it just goes between negative 1 and 1. If you do inverse sine on your calculator, it will actually say math error, so that will also tell you no solution. Sine x plus 1 equals 0 means sine x is negative 1, and that's another one where you can look at your graph and you should be able to find out that it's 270 degrees. So when we look at all this together, that's actually our only answer for this question. 270 degrees. So 3 different methods that we use there, all involving factoring. We can also have coefficients at the start here for this, so we'd use our slide and glide technique we learned, and that should enable you now to attempt the worksheet.